the recording. And then we are going to share screen. So probably today, mostly I will start with drawing a lot of stuff and explain. So today we are going to learn a new concept. It's linked list. I cannot, this pen not working. No, I already initiate the, okay, now it's not sure why that the other pen, okay. So today what we discuss is a linked list, okay. So linked list is also used to store a collection of items. So we previously we learned like array, etc., and stack and the queue. Stack and the queue both have their features. But when we discuss the implementation of stack queue, we discuss the implementation using array, etc. So linked list is another kind of concept, also used to store collection of items. So it's a store collection of items, okay. And the general idea, array, we all quite familiar, is it? So if I draw something, it's going to be kind of one by one, is it? Very adjacent to each other, is it? To each other. And in memory for array, generally speaking, whenever we do the array, we do new, it's going to allocate the memory on heap, is it? And in array's case, then each of the element, is it? So this is element of array. So the element, is it? They are all one after the other. So one after the other. So even in memory store, is it? It's kind of just like in apartment, room by room, or like in our building, is it? One room after the next, but it's next to each other. Okay, so the concept here is next to each other. Or we can call this kind of allocation, it's memory allocated continuously. So that's the kind of concept for array, okay? It can be used to store a collection of items. Oh, I need to turn on the, I just get it, where my annotation? How about I will stop reshare? For some reason, I just click, then the annotation is gone, my pen is gone. Okay, and then let's take a look at linked list. Linked list. Linked list, the concept is a little bit different, okay? So if I draw it visually, it's kind of look like this. So you will have a bunch of things kind of connected together. Okay, connected together. It's kind of like this. So in memory, then what it happens is you may have this node created. Okay, and the other one, the next one to it, it's not like in array next to it. It may be somewhere here, is it? And then it's connected together. And the other one then may be here, is it? And then this guy connected to it. So that's, so memory, regarding memory allocation doesn't necessarily to be contiguous memory allocation. So that's a concept just to visually, okay, about linked list. So linked list, based on the name, is it? So it's linked, is it? And using something linked together to create a list, okay? And so what is the thing that we linked? Is it? So basically in linked list, the basic unit, or we call it a building unit. For linked list, we call it, it's a node. So that's a new concept. Okay, it's a node. So if I draw it, it's something like this, a node. Okay, a node, generally speaking, has two parts. Okay, it has some information part. So generally, the information is going to be used to store contents. Okay, store content. So whenever, like, if we define the information, and yesterday we learned generic, etc. So it can be like a type, very generic type, T, etc. And the T basically can be anything else, etc. Like a concrete type, then it can be integer, it can be string, and it can be employee, can be account, etc. So all sorts of class stuff. So that part we call it information, but it has another part, the second part. And it's, if we draw it, it's kind of like an arrow. Okay, so what this is, it's a it's point to the next node. So the type of it in Java, it's also a node. It's also node, but it points to the next. Point to the next node. So because of this arrow, that's why you can have all of the nodes connected together, because then you can have the next. And you use this arrow to point to the next node. Okay, so the node structure itself kind of also look like a little bit of like the recursive concept we learned, but this is not recursive. Basically, it's for a method, not to apply for data structure. But this structure itself also kind of, like some recursive concept, because you have a field, and then the field is itself, but it's point to the other node. Okay, so the basic building component, or we call it a component, of a linked list is this, visually it's this, okay, when we call it a node. And a node has two parts, okay, has information part. So information is whatever you're going to store in it, okay. And the other part, we call it a next. And information, generally speaking, if we going to write as a generic class, then it's going to be type T. And the next, then the type is a node. Okay, so this is the concept. So conceptually, a node looks like this. So always remember there are two parts. One part is all of the information you want to store in it. And the other part is looks like a arrow, but the type is a node itself. But where it pointed to the next node. So that's the general idea. And if visually, you can also think of this like on railway, like Amtrak, okay, or railway cart, and it looks something like this, so you have a car, and then you have a hook. So here you have a hook, and then the hook going to hook the next cart, and then it has a hook to the next cart, and it has a hook to the next cart. Oh, it should be the square, So it can keep doing like this, So this is like on railway, the railway, like Amtrak something, or we all know like necklace, or you have a bunch of bees, and you can chain them together, So all of this kind of the real world thing, and they are also connected, one after the other, and this kind of concept, you use some basic building component, like the railway card, is it? And then you connected all of them together, is it? So this kind of implementation is a linked way implementation. This concept is different from array, is it? And it's linked way because in memory, is it? In memory, your node can be first allocated like, so here is your memory, suppose, is it? And the second one may be here, is it? But that node is going to point to it. And the third one may be here, is it? But this arrow going to point to it. So in memory, it's not necessary to be in sequence, one after the other, not like array. Array got to be, so if it's array case, then it's the first, the second, the third. Okay, so it's all going to be one after the other. But the linked way, you can see it's quite flexible, is it? Okay, then let's see. So we know the basic building concept is a node. And a node has two parts, okay? Information part, and the type, generally speaking, is some T type, generic. And we also have a field called next, and the type is a node. That's a basic building unit, and it looks like this. Okay, so this is information, and the arrow is next, we call it, okay. And then next, what is a linked list? Okay, so then a linked list is you use a number of nodes, and then you connected them together. So I have a number of nodes, and then I can connect them together. Okay, I draw like this. And be careful, the last one I draw kind of like in physics, when you draw the voltage, is it, when you draw some electric wire connected to the ground, is it? And you draw something like this, is it? So, and over here, I draw the last one, looks like that, okay. And then you see, I have a number of nodes over here, and I connected them together. That's always through this next, get connected together, is it? And then this whole thing, we call it a linked list. Okay, a linked list. And think about like this case, like the railway, okay. And we have the hook connected together. Okay, and for the railway, then you have a driver. That the driver going to drive the Amtrak, is it? And it's always at the very beginning, is it, of the carts. Okay, the Amtrak. So that is the first cart, is it? And all of the remaining going to be driven by this very first one, is it? And identify also by the first one, is it? And in the case over here, we can assume, okay, and suppose you are at here, okay, the very first one, is it? And if you wanted to go to the last cart, if you want to get to the last cart, then in this case, how did you do it? So then you need to first get to the second cart, and then the third, and then to the last, is it? You need to go through every single one, and then to the last. Okay, so if you start at the very beginning, okay, and so for our linked list, then there's some similarity is we also need to have something to identify who is the first, is it? So yes, so the very first node that you created and you start to build this linked list, and we call it a first node. Okay, We know the first node. And then let's see, if you know the first node, if I know the first node, and the type of this is also a node, is it? And once you know the first node, do we need to know anything else if I wanted to know this whole linked list? Basically, you can see you don't need. If you know the first, then basically you know the whole linked list. Okay, why I see that? Because you see, once you know the first and through the first arrow, is it? You can get to the second node. Okay, you can get the second node. And through the second node, it's next. Then you can reach the third one. Is it? And through the third one's next, then you can reach the fourth one, is it? And all the way to the last one, is it? Okay, but then the question is, how can you know any of these nodes are the intermediate nodes? And how can you know this is the last? Is it? And that's because if we take another closer look, the last one node and it's next. It's next. Does it have any other nodes? No. Is it? So last nodes is next is what? It is a null. Okay, it's a null. It doesn't point to any other node anymore, is it? So if I know the first node, basically for linked list, then I know the whole linked list, is it? And I can always store all of the information I needed to all of the nodes. And when I needed to get to the information, then I can also start to retrieve the corresponding information. Okay, so that's the concept here. So for a linked list, basically linked list, you can use which information to identify the linked list. So the case is if you know the first node, okay, then we know the whole list, the whole linked list. Okay, so that's the concept here. Okay, so and once we know this, for a linked list, basically you just need to know the first node, is it? Then here the concept is different from array, is it? Just think about for array. Is it array? Then you have index, is it? To access all of the elements, is it? So basically you know every single element. And the element accessible through what? Through the index. This through index. So you can directly access any element using the index. Okay, so that's the concept of array. But for linked list, for our linked list, we just said you basically only know the first node, is it? You only know your first node. So how do you get to of the other nodes or some nodes that you want to get, is it? Then you always need to start at the beginning. Is it? You always need to start here. Okay, and suppose you want to get somewhere here, is it? Then the only way is you need to go to the second and then from second to the third, is it? So this kind of operation, so starting from the first and then go to the next, then go to the next, this kind of operation, we call it traversing. So just remember this word, okay, traverse, okay, traversing. So traversing the concept in linked way implementation. So here is regarding linked implementation. Okay, so the definition for traversing is is what? Is node by node visit. Okay, there is no index, no indexing for you to directly access to certain item. Okay, any item you want, you need to start from the beginning and then do some traversing to get to that node. Okay, then you may say, oh, then how inefficient linked list is. You see, we have array and we can access directly, is it? So array, it's quick access via the indexing, is it? Very quickly access, is it? But you remember previously we discussed the circular array way implementation of queue, is it, of queue. And array, yeah, it's very quick to access, is it, in for any element anywhere, okay? So quick access any element anywhere, is it? But just think about insert and delete operation anywhere. Therefore, array, because array is in sequence one by one, is it? And if you want to do some insert, then what do you need to do? You need to do a lot of shifting, is it? And delete, the same thing, you need to do a lot of shifting. And if you just have a small array, it doesn't matter too much. But if you have huge array, millions of items each time, if you insert an item or delete an item, it involves a huge amount of shifting work, is it? So regarding insert or delete anywhere, then it's not efficient for array, is it, for array? So if you have any operation that involves a lot of insert and delete, numerous insertion and deletion operation, then that's not efficient, okay? And on the other hand, is array each time when you want to use it, is it? You need to do new, is it? And the new, then the whole block of memory allocated, is it? And suppose you at one time you allocate 1 million block of memory, but you only need 10 of them to use. But then you reserve all of the remaining memories, is it? So if you don't use that, but you allocate them, it's kind of a waste, is it? And the versus linked list, then is, okay, each time if you want to use, you allocate, is it? A single node's memory. And each time if you want to use, then you allocate that much of memory, is it? So even regarding the memory allocation, the linked list is also very flexible, is it? And it's not just this, it's what I just explained, is with numerous insertion and deletion, okay? So insertion and deletion, then in memory, if we draw it, oh, you have a node, is it? And then this, suppose it's connected to this one suppose it's connected here, is it? And then this guy, suppose connected to here, and it's connected to here. It's all randomly located, but can be connected together, is it? And then just think about each time if you have a new item, suppose I have a new item and I want to insert, is it? And I want to insert between these two nodes. Then how do I insert? Oh, you find some available memory location, is it? And you create the node here, is it? And what you can insert, you see, you just need to change the arrow, is it? The next node's pointer, is it? That's all you needed to do. So no shifting here needed, is it? You just needed to repoint the arrow, is it? So this is quite flexible. There's no shifting involved. So that's why if you have numerous of insert and delete, then it's quite convenient. Okay. So over here we explained the advantage of linked list and why we need it. Is it so linked list? Then it's very efficient for insertion or deleting anywhere. That's very efficient, okay, but not so for a linked list, there is no index operation, okay? Because each time if you want to retrieve something, then you got to start from the very beginning and do the traversing, okay? So in regarding to access any item, any element, and the linked list is slow versus array, okay? So that's a linked list. So general concept, I believe you already got some idea about linked list. So linked list conceptually is just a bunch of nodes connected together, okay? So that's our linked, and it's linked list identified by the first node, and generally we call it a first, okay, call it a first. So next, let's then see how do we create linked list. Is it that data structure in code? Is it? So first I explain conceptually, okay. And generally, whenever we discuss the operation, and if you recall what we already discussed, stack and queue, is it? What we care a lot about those kind of data structure is we always need a constructor. The constructor's purpose is to do what? To create an empty create an empty ADT, okay? And ADT is abstract data type. So abstract data type, okay? So we always need a constructor. And if you recall when we discuss stack and queue, we also discuss the empty function. The empty function to see if both data structure and empty, is it? And then we also have add operation, is it? So add a new item, is it? And delete operation, is it? Over there we call it push, pop, is it? Or in queue we call it in queue, is it? Something like that. Is it? Over here we call it pop or DQ. DQ. So those are general operations, is it? And we also have for the stack, you also have like the top operation, because you can only access the top item, is it? And for queue, then you have that operation, we call it front or pick or element, is it? Something like those. Okay, so those are major operations, generally speaking, we care about, is it, for certain data structure, is it? So similar concept, is it? So for our linked list, linked list, then what kind of operation we care about? Is it, and of course, we also care about constructor. Is it constructor? And we also want to know if the list is empty. Is it? And for linked list, we said its benefits. So its advantage is insert and delete. Is it? So over here, then of course, what we care about is insert something and delete something. Is it? So that's what we care about. And but another very important operation in linked list, generally speaking, versus stack and queue, we already learned is in linked list, what we care about, it involves a lot of node by node visit. Is it? Because sometimes if you want to get an item, or if you want to find an item to do insert and delete, you need to find the item. Is it? So that kind of operation, we call it traversing. Traverse. So that's an important operation. So generally speaking, if we want to create a linked list, and then those are the very basic operations that you need to provide. Okay. And previously we also learned, like whenever you create a class, is it generally you can use UML diagram to kind of give the general framework of your class. Is it? Therefore, our linked list is similar. Is it? So if we need a linked list, then we need some private instance variable. Is it? Then in this case, like I just explained, it should be that first node. Is it? And what's the type it should be? It should be a node type. Okay, and we need to define this node type. Is it? And the major operation as what I just described. So it involves some constructor, is it? An empty function, and insert, and delete, and the traverse. Is it? So of those. So that's generally speaking regarding the UML diagram. Okay. And then next, let's see. For the linked list, we said we constructor. So the constructor, the default one is create an empty linked list, an empty one. So what's the definition for an empty list? Is it? And the linked list is identified by the instance variable. Okay, first. So that's its instance variable. And the type is what? Is a node. Is it? So how do we say it's an empty list? An empty list, that means this first just point to a node, because there is no node exists. It's an empty one. Is it? So basically, if you set the first to a node, then we create an empty list. Okay, then the same thing, how to check a linked list if it's empty, then you can also do this. Okay, so that's the general concept. Okay, and then next, let's see. Suppose over here I have a integer linked list. Okay, I have 100, 200. Suppose it's already built. As how do we build it? Later on, we are going to see. Okay, then we have 300, 400, and the next is 500. Okay, 600, something like this. Is it? And all the way supposed to 900, something like that. Is it? And so the first thing, let's take a look. How do we do traverse? Is it the traversing? Traversing is what? Is defined by node visit. Okay, node by node visit. So, and we only know the first node. Is it first node? I suppose what the traversing going to do is I'm going to output all of the nodes information. It's kind of like the toString function. Okay, suppose you're going to write the toString for the linked list. Then how do I get the 100? The 100, then you can get through, because it's the information part of this node. Okay, the node is a class also, is it? And then you will get what? You will get that 100. Okay, and then the question is, how do I get to the 200? Is it? So you only know first, is it? How can you know the next one? Is it? So basically, conceptually, you can do this, because the node has two parts, is it? So through its next. So first .NET is going to be this node. So now you know the second node, is it? And then you can get its info, is it? That will give you 200, is it? And then how can I get to the 300? Oh, you see, oh, 300, yeah, that should be simple, is it? It's through what? Through second node's next, is it? Second node is who? Is the first next. So then you see, oh, I can add another next. Then it's going to be the 300, is it? And then once you know 300, then okay, I know 400. Is it? How do I get to know 400? You add another next. Is it? Add another next. So now you are at the 400. Is it? And the same thing, you say, okay, 500, I can add another next. Is it? Then I get to the fifth node. So if you have a million, then you can keep adding next. Is it? That's not the way to write a program. Is it? Even though conceptually this is achievable. Is it? You can keep through call .next, .next. Is it? But that's not an efficient way. Okay. So then how do we do that? This kind of traversing. Is it? Okay, so the concept to do traversing is something like this. Suppose we only have this much of node. So we have 100, then we have 200, 300, 400, 500, and 600, is it? And we know the first node. Okay, we know the first node. So, and we just see you can through the next, the .next, get to the next node, and then through next node .next, get to the next node. Keep doing like this, is it? But that's what we just said, it's not efficient. So generally, what we do is we can borrow some variable, okay? Suppose a variable, we call it a cursor, and the cursor's type is what? Is a node. Okay, of course, you can define something like this, is it? And then you let your cursor, you set it to the first. Is it? This is achievable, is it? And then how can I get to the second node? Okay, then the second node, you can get access to as what? It's cursor's next. Is it? Cursor's next is going to be 200 in this case, is it? But you can reset it to cursor. Is it? You can reset it to cursor. Is it? And then in this case, okay, cursor going to point to the next. Is it? And if you keep doing, is it in your next iteration? So you can use a loop. Is it? So within the loop, you see, you keep doing this. Then your cursor is going to move to the next, to the next, to the next. Is it? This is kind of like you are on the Amtrak. You start from the first card, is it? And you walk through all the way to the last one, is it? So you use a loop, then you use that temporary node, is it? And you always set it within the loop to the .next, is it? Then you can get access to the next node, is it? And when can you end, is it? So generally speaking, over here, the loop is, oh, while the cursor is not a null node, is it? Then you can always do cursor equals cursors next. Is it? If we want to just kind of do the output, suppose printer, then over here you can plug in, oh, like the system.out print line, is it? With a cursor dot info, is it? And if you keep calling this, then the 100, 200, 300, then they are all going to be output. Okay, so this kind of concept, we call it traversing. So traversing. So to achieve traversing is you use some temporary node, a variable, okay? And initially you set it to first, okay, set it to first. And then in your loop, you reset it to itself next, to itself next, to itself next. Okay, then you can keep moving your cursor. They keep moving your cursor until your cursor is at the null, then you're going to stop. Okay, so this kind of concept, we call it traversing, okay? Okay, once we conceptually understand traversing, and then let's see, let's see how do we insert. Okay, and when we do insert, there are a number of cases needed to think about it, okay, think about it. So the very first case, whenever you want to insert, initially it's empty, is it? How do you insert, is it? So you first need to check if the first is a null pointer, is it? If a null pointer, then you basically need to create the first. Is it? You create the first, then you can call the new node. The node, suppose it's some kind of data structure, okay, class, and we will see it in code. But anyway, suppose that class already exists, okay, then you're just going to create it. Is it? Create this node, okay, and then basically that's the first case, okay. So you do the insert. So case one is empty list. Empty list. Then you do this, is it? And case two is, suppose you already have a linked list. It's already here, is it 100, 200, is it? And the first is here, is it? And you said, oh, I want to have 50 be added. And I want 50 be added at the very beginning, is it? So how do I do these cases? So this is second case. So case two is insert at beginning. Is it at the beginning? Then in this case, you first need to create, this is a new node. Is it? This new node, you need to create it. So basically it's a node, new node. Is it? And you can create, call new node and something. Is it? You insert, in this case, 50. Is it? You create this new node. Okay. And you need, you cannot, you create a new node, it won't automatically go to the linked list. Is it? Because it's not connected together yet. Is it? So you also need to do what? You need to connect it with the first node of your linked list. Is it? How do I achieve that? So it should be new nodes. What? Its next should be what? Should be that first. Is it? Then you add it ahead of the first. But you add ahead of the first, the linked list is still going to be identified here. Is it? Through here. That's your linked list. So you haven't updated your linked list. And if you do want to update your linked list, then you need to reset first to the new node. Okay, then in this case, you got the new node added to the front of the linked list. Okay, so that's the second case. The third case is over here, is it? And so this is 100, 200, 300, and something else. Suppose this time you have 250, and you want to insert the 250 between 200 and 300. So how do I do that? Is it? So basically in this case, then the first is you need to identify you're going to insert after 200, this specific node. Is it? Suppose you found it. This is called cursor. Okay, we found it. After we found it, then we need to get this. So this is our new node. Okay, you created. This is case 3. Case 3. So it's insert in the middle. And this also apply, we will see at the end. Okay, and so we have this new node also created. So how can I get 250 inserted between 200, 300? Is that okay? You set what? New nodes. You need to reset because when you create, it's an empty. It's pointed to a null. Is it? So now you need to reset its next to where? To 300. So who is 300? 300 is cursors next. So you need to set cursors next. Is it? Set it to cursors next. And then what? Then you need to reset cursors next to this new node. Okay. So then you need to do, okay, cursors next equals new node. Okay. And after you finish this, then this 250 got inserted. Is it? So the step to add a new node between two existing nodes is you first need to do what? You first need to create a new node. Create a new node. New node. So that's the first step. And the second step is what? You set new nodes next to cursors next. And the third step is you set cursors next to this new node. Okay, then you can insert this new node in the middle of an existing linked list. And this also applies to insert what I just said at the very end. Is it? At the very end, basically, you see, this is just a null. Is it? So new nodes next, cursors next, basically it's just a null. But the cursor next, it's still null. Is it? So this is okay. And then you insert, okay, cursors next point to new node. So this, the code itself will apply to both cases of insert in the middle and insert at the very end. Okay, so that's all the general concept. Okay.